Well, thanks for the invitation. The presentation is about water for the future, Chile's approach. Some highlights of Chile. Mining activities represent about 56% of exports, 10% of our GDP. Chile has about 214,000 skilled workers. Foreign investment in mining represent 18%. And in Chile, we have more than 5,000 companies, mining suppliers. Where is located Chile? In South America, but most mining in Chile is concentrated in the very north of Chile. Some important operations are, for example, Escondida, Spence, both BHP companies, Chuquicamata, Coyahuasi, and others. As the photographs show, the north of Chile is one of the driest areas of the world. What that means? Water scarcity. What about the water consumption at copper industry? The Chilean copper mining industry has three sources of water: continental water, seawater, and recycled water. The slide shows that the industry use of continental water has remained steady in the recent years, while the use of seawater and recycled water have increased. What about water consumption by process? 5 different areas of water consumption can be identified. Concentration, hydrometallurgical process, smelting and refining, mine and services. The most important area of consumption corresponds to concentration of sulfide minerals, which accounted for 67% of total. The concentrator plants are involved the processing of the mineral and represent the largest consumption of water in terms of volume. This slide presents the unit coefficient of use of continental water per ton of mineral process for both the concentration and hydrometallurgy processes. The unit coefficient for concentration has shown a sharp reduction. This is mainly because although the quantity of mineral processed has increased, consumption of continental water has not increased to the same extent, because the Chilean copper mining use more water recirculated. The forecasting the copper industry water demand. The production forecast is the pillar of the water consumption forecast because it determines the amount of mineral that would be processed between 2018 and 2029. Using the annual information provided by different copper producing operations, unit consumptions can be obtained of each of the 2 main methods used to process mineral, based on tons processed in the case of concentrators and electro-obtained cathodes in case of hydrometallurgy plants. What is the expected copper production? As forecast for the next 10 years, based on the conditionality of materialization of the projects included in the 2018 survey, it shows an increase of 21% by 2029 as compared to production in 2018, implying a fine copper output of 7 million metric tons in 2029. When disaggregate by type of product, the forecast confirms a trend under which hydrometallurgical production is falling, while production of concentrate is growing quickly. Water of continental origin is a scarce resource. This represents not only a hydrological limitation, but also increasingly an economic problem that could restrict the development of the vast majority of industrial activities. Chile also has the potential to use seawater in short term. This represents an alternative for addressing the limitation that this transcendental resource poses for many areas of the country, and not only for mining, but also many other economic sectors. As a result, seawater consumption in 2029 is expected to be up by more than 213% on 2018, accounting for 43% water required by country's copper mining industry. What is expected water consumption by region? Over the coming years, use of seawater will show the greatest development in the Antofagasta region. This is the Antofagasta region, here, where it will permit decrease in consumption of continental water. In this region, there are operations already using seawater, like Escondida, Centinela, Antucoya, and others. A number of projects in this region also envisage use of this resource. The use of continental water shows a very marked decline in Antofagasta region and a little change in other regions. Only one region shows an increase the use of continental water, the Atacama region. What about the consumption by status of environmental permits? In Chile, all projects must obtain a resolution of environmental approval. This is awarded only after a technical administrative process that includes citizen participation as well as analysis of the project's environmental impact study. Most water consumption correspond to operations for which environmental permits have already been granted, classified as EIA not applicable in this slide, this one. They are followed in terms of amount of water by project whose environmental impact study has been approved, or in other words, mostly projects that are under implementation or have to replace or expand existing operations. In the specific case of the expected consumption of seawater, the situation is different. With a solid base of new projects, future demand for seawater will depend heavily on the award of environmental permits and the regulatory framework to use of this resource. The use of seawater in mining. In 2017, the copper mining industry consumed 1.63 cubic metric per second, correspond to seawater used directly, and 1.53 cubic meter per second water that had previously been desalinized. At least 8 new projects using seawater are planned, as well as 4 expansion and or replacement of existing systems. Seawater supply must consider first importance of pretreatment, because we have desalination plants and plants without desalination. It depends of each operation. It's necessary, it's necessary a public-private coordination. Why? Because it's necessary a study in the future the possibility to, for example, share the use of water between different operations or between other industries in Chile. Third, maintain high environmental standards, consider social impacts, and something very important is the energy-water nexus. Most new mining projects consider seawater as our source of supply. Seawater has high energy consumption, mainly to pump the water from the coast to the mine site. Final remarks. The mining industry faces three strategic long-term risks related to water. First, to ensure sufficient water for production increases. Second, to reduce water and energy consumption and emissions in line with social, environmental, and economic pressures. And three, to understand the links between water, energy, and emissions so that an improvement in one area does not result in a greater adverse effect in another. Finally, it is essential to analyze the problem of water supply in regional context, seeking possible synergies that would reduce cost and contributing solutions not only for mining, but also other sectors based on their future demand that take advantage of economies of scale and therefore achieve a design that is as efficient as possible. Thanks.